Hi again, everyone. Dr. Tom McNamara back for our course in college algebra. I wanted to discuss the idea of a piecewise defined function in this video. So a piecewise defined function is one that uses different rules for different inputs. So let me give you a scenario where this will be helpful. Okay, so pretty simple idea. We have a 5-gallon bucket, like that kind you can get at Home Depot or Ace Hardware. You get a 5-gallon bucket. We want to fill it up with water. We're filling that bucket up with water, and we're going to pretend that our tap puts out half a gallon of water every minute. Okay, so naturally the amount of water in the bucket depends on how long it has been since we have turned on the tap. Okay, so our input will be time. Our output will be gallons in the bucket. So I want a rule that tells me how to take the time since the faucet has been running and produce the amount of water in the bucket. So let me I'll make a little table here. We'll just do some numerical computations. Okay, so if we have been letting the water run for 1 minute, well, the tap puts out half a gallon per minute, so we'd have half a gallon there. If I let the water run for 2 minutes, we would have 2 half gallons in there, or 1 gallon. If I let the water run, let's say for 6 minutes, then I would have 3 gallons in the bucket. Right, a half a gallon every minute, so you have half a gallon, 1 gallon, 1.5 gallons, 2 gallons, 2.5 gallons, 3 gallons after 6 minutes. Okay? I guess the easiest thing to do is just multiply your time by 1/2. Okay, take 1/2 the time, and then that gives you the amount of water in the bucket. Sort of. Let me show you what I mean. If I let the water run for 10 minutes, then I would have 1/2 of 10. In other words, 5 gallons in the bucket. If I let the water run for, 14 minutes, well, some people might be tempted to say we'd have 7 gallons in the bucket, because we just said that the rule for finding the number of gallons in the bucket is you take 1/2 multiplied by the time. Okay? So if we apply that here, 1/2 times 14 is 7 gallons. However, we run into a bit of a problem because this is a 5-gallon bucket. So you can't have 7 gallons in a 5-gallon bucket. Remember, the output is not the number of gallons that have come through the faucet, it's the number of gallons in the bucket. So 5 gallons in the bucket. If I let the water run for 20 minutes, 5 gallons in the bucket. Now you may have a lot of water on the floor or on the ground if you're outside, but the number of gallons in the bucket is still going to be 5. Okay, so if I were to draw a graph of this function, let me show you how it would look. It would look something like this. 10 is kind of the important place for this function. Okay, the amount of water in the bucket would steadily rise at the rate of 1/2 gallon per minute until we hit the 10-minute mark, at which point the number of gallons will stay at 5 and it will remain there forever. Okay, so it's like we have 2 different rules that we're using for our input. If the input is between 0 and 10, then we use the rule take 1/2 the time, and that tells you the gallons. If your input value is greater than 10, then we use just plain old 5, and that's your output. That's the rule that tells you how much is in the bucket. 5 gallons, 5 gallons, 5 gallons from here on out. Okay? So we might say there's basically a decision being made. So you're going to input T. So we input a T value there, and then we have a choice to make. We're looking at this comparison. Is T less than or equal to 10? If our answer to this question is yes, then here's how we find our output. The output is 1/2 T. If the answer to this question is no, well, that would mean the input is greater than 10. So our output would be 5. Okay, output would be 5 in that scenario. Okay, so we have a special notation for these piecewise defined functions because we have a couple of rules that we might need to follow. So we put those rules on separate lines. So it would look like this. G of t equals 1/2 t if t is less than or equal to 10. G of t equals 5 with no t at all. The output is just 5 and that's it. If t is greater than 10. Okay? Now, if you're given an input to a piecewise defined function like this, you are going to use only one of these rules. So you're going to use exactly one rule. I give you an input, you are going to take that input and use exactly one of those rules on that input. How do you determine which one to use? Well, you look at your conditions. If your input meets the condition on the first line, then you use this rule, which says you take 1/2 times the input. If your input meets the condition on the second line, use that rule, which says the output is 5. Okay? Let me give you a second example of a piecewise defined function. Okay, so let's do this one. F of x equals 2 minus x if x is less than -1. X squared plus 3x if -1 is less than or equal to x, but x is still less than 2. And 1/2 x plus 3 if x is greater than or equal to 2. Sometimes on the last rule they just say otherwise. So you've checked this, you've checked this. If neither of those work, then you're down here. Okay, so the problem might look like this. Given this function, evaluate each. Okay, so I'm going to evaluate some outputs for this function. Okay, let's start with this. Let's do, I don't know, f of 1. Okay, so 1 is my input. Now I'm going to apply exactly one of these rules to my input 1. The question is which rule? Well, I'm looking at my input. Is my input less than -1? No, it is not less than -1. My input is not less than -1, so this rule is out. Is my input between -1 and 2? Yes, it is. So this is the rule that I use. And that rule says you take the input and you square it plus 3 times the input. So you get the output of 4. Input 1, output 4, using that rule. How do we know we use that rule? Well, our input met the conditions that tell us we use that rule. If I were to do something like this, f of 8, well, I take my input and I look at the various conditions. Which condition does it meet? Is my input less than -1? No. My input is positive. It's greater than -1. Is my input between -1 and 2? No, it's actually bigger than 2, so it doesn't meet this condition either. It meets this last condition. The last condition says the rule that I should use is I take 1/2 the input plus 3, 1/2 of 8 is 4, plus 3 is 7. Okay? And if I did one more, if I did, let's say, f of -3, all right, well, I got to look at which condition my input meets. And we can see right away, -3 is less than -1. We meet the condition on the first line, so we apply that rule, which says to find your output, you do 2 minus your input. 2 minus -3 gives us 5. Okay, so piecewise defined function, pretty easy to understand once you know what all this business means. Okay, so if you're given an input and you have to use a piecewise defined function, and you'll be able to tell it's piecewise because it has these multiple rules. You take your input, you compare it to the conditions over here. Look at which condition it meets, and that determines the rule you use. In this last example, we met the condition on the first line, so we use the condition on the first, so we use the rule on the first line. Right here, f of 1, we meet the condition on the second line, so we use the rule on the second line. Okay, so piecewise defined functions give us a way to deal with scenarios where different inputs require different rules. And it actually comes up fairly frequently. Okay, so not too hard to deal with once we know what all that means.